welcome back to EC TechNest. In this lecture, we'll be discussing about the module 2 of embedded system design. So, the first concept is characteristics of an embedded system. This is one of the very most important repeated question in every exam. They'll ask to explain the characteristics of an embedded system. So, now we'll discuss about the characteristics of an embedded system. Embedded system has 6 different characteristics. So the first one is it is application and domain specific, which means each embedded system is designed to perform its function only to that particular application, and it is also related to that domain only, and we cannot replace the embedded control unit of refrigerator to the microwave oven, which means it is task specific as well as application specific. Next is it is reactive and real time, which means the use of sensor in a embedded system would be to get immediate response and also produce changes in output with respect to the input. And also timing behavior of a system should be deterministic, which means we should be able to predict at what time or within what time the system will respond. And that's why example would be anti-lock brake system. Next one is it operates in harsh environment. Embedded system should be developed with the stand in all the adverse operating conditions, which means it should be able to withhold the harsh environment around it. And example would be if a system is deployed in high temperature areas, the components used in the system should also have the capacity to manage the temperature. And also power supply fluctuations, corrosion, and component aging, etc. are the factors that need to be taken into consideration. Next one is the embedded system is distributed, which means it is formed by many distributed embedded system. Example would be ATM, supervisory control, and data acquisition system. It is called as SCADA. Next is embedded system is small in size and weight. The more smaller is the size and weight of the embedded system, more convenient it will be to handle, and also the compactness is also a significant factor. Applications demand small sized and lightweight products. Next one would be power concern. In power concern, most of us would like to purchase those embedded systems which consume very less power, and low power dropout regulators and controllers with power saving modes are also preferred. And power concerns mainly depend on the battery life also. So the next concept that we'll be discussing is quality attributes of an embedded system. There are two types of quality attributes in an embedded system. It is operational and non-operational quality attributes. In exam, they'll ask either one of these quality attributes, either operational or non-operational quality attributes. So in case of operational quality attributes, you have to write about the operational mode is also called as online mode, and you have to write about response, throughput, reliability, maintainability, security, and safety. You have to explain about each term in detail. So response is the measure of quickness of the system, and it gives us how fast the system is working. Example would be system deployed in flight control application, which is time critical, which means the response is immediate. And next one would be throughput. In throughput, it mainly deals with the efficiency of a system. It is defined as the rate of the production or operation of a defined process over a stated period of time. Throughput is generally measured in terms of benchmark, which is set of performance criteria that the product is expected to meet. And next one will be reliability. Reliability is the measure of how much the system can perform and what is its susceptibility of the failure. Here we will discuss about two terms, that is MTBF, which means mean time between failure, and MTTR, which means mean time to repair. Mean time between failure is the frequency of failures in hours or weeks or months, whereas mean time to repair specifies how long the system is allowed to be out of order and also following a failure. So the next one will be maintainability. Maintainability mainly deals with the support and maintenance of the end user in case of any technical issue. The complementary areas would be reliability and maintainability. In maintainability, there are two types of further classification, that is scheduled or periodic maintenance or maintenance to unexpected failure. So scheduled or periodic maintenance means when the inkjet in the printer is empty or the is about to finish, the user needs to replace it on a periodic basis. So this is scheduled or periodic maintenance. Whereas maintenance to unexpected failures would be the response to a system in which the user has not expected any failure and it was like an interrupt that occurred during the maintenance. So the availability equation is given by mean time between failure plus mean time divided by mean time between failure plus mean time to repair. So the next one is security. Security measures the information security such as the confidentiality, integrity and availability. In confidentiality, it deals with the protection of data from unauthorized access, whereas integrity also deals with protection of data from unauthorized modification, whereas availability is protection of data from unauthorized users. So the last one is safety. It deals with the possible damage that can happen to the operators, the public or environment due to the failure of the embedded system. So the 6 points need to be explained when it's asked question based on the operational quality attributes. Now moving on to the non-operational quality attributes. Here we have testability and debuggability, evolvability, portability, and time to prototype and market, as well as the per unit and total cost. So first we'll discuss about testability and debuggability. Testing of an embedded hardware ensures that the peripherals as well as the firmware is functioning properly and in an expected way. Debugability would mean rectifying the errors both in the hardware level as well as in the firmware level. Firmware level debugging would be figuring out the issues created or errors that appear as a result of the failure in the firmware. Next is evolvability. Evolvability is referred to as non-heritable variation, in which the embedded product can be modified to take advantage of the new firmware or hardware technology. Next one is portability. Portability is measure of the system independence, which means how well a system can perform without any support from the operating system. And the next one is time to prototype and market. Time to market is the time taken by a design or a product to make it ready for selling or use. Next is per unit cost and revenue. Cost is highly sensitive factor for commercial products, and to get a marginal profit, the budget and the total system cost should be properly balanced. Next we'll discuss about the product life cycle, also called as PLC. This is also a possible question that is asked in exams. Explain the product life cycle or PLC of an embedded system. So there are 5 different phases in the product life cycle. First one is product development. Second one is product introduction. Third one is product growth. Fourth is product maturity. And fifth one is product retirement. And the graph is plotted by taking the x and y axis to be time and revenue. You have to plot the profit per unit cost as well as the product sale. Initially, product is developed and therefore there is no income, unit cost, profit or product sales, therefore it is empty. And the total revenue increases from the product introduction stage to the product maturity stage, and the revenue peaks at the maturity stage and starts falling or decline when in the retirement stage. Profit will be high and attains steadier value and falls with dip in sales. So negative value of profit is because initially only investment will be present and profit ratio of profit is very low, that's why it's negative. Next, coming to the application specific embedded system, we'll discuss about washing machine. In most of our home we use washing machine, and you have to explain the count of the sensor and what type of sensor is present in the embedded system and what are the parts that a washing machine has, that is motorized agitator, tumble tub, water drawing pump and inlet valve to control the flow of water. Next, you have to explain the amount of LEDs and sensors. So, and you have to explain the phase of washing. Washing machine comes in different design, that is top load and front load. In top loading model, the agitator of the machine is twisted back and forth and pulls the cloth down to the bottom of the tub. On reaching the bottom of the tub, it then grabs and moves to the top and repeats the mechanism. Next is LECU, which means low speed electronic control unit. They are built around low cost microprocessor or microcontroller, and example would be audio controller, passenger and driver door locks, etc. In the further lecture, we'll discuss about few more topics in this module. Thank you.